Right, okay. Students, can you all hear me? Can you hear me? Right, okay. Right. So, good evening for all of you. Friends, today we are going to conduct organic chemistry reaction practice session number 4, right? So, I think we discussed many reactions up now. So, we did some conversions also. So, today also we are going to learn some new reactions, and we are going to do some conversions related to those reactions we are going to learn, right? Okay, so today the first reaction that we are going to learn is carbon atoms increasing reactions. Carbon atoms increasing reactions. Number 4. Increasing reaction. Number 4. Right? So remember, this is known as actually Friedel-Crafts acylation. Okay? Friedel-Crafts acylation. So this is the reaction. So let's see what does mean by this Friedel-Crafts acylation. So Friedel-Crafts acylation means we can consider that when we have a benzene ring in this way, right? So this is the benzene. Here we are going to add acid halide, RC double bond C. We know that for the acid halides, the common, the functional group that we can identify acid halide is C double bond Cl, right? Mostly chlorine or bromine, right? So therefore, this is acid chloride. Just imagine this is acid chloride. In order to react with this benzene ring, here we are going to add anhydrous aluminium trichloride as a catalyst. Remember, this is a catalyst. And then what will happen? Remember, students, here this is very easy. What will happen here? We know that in the benzene ring, there is an hydrogen atom, right? We are going to learn the reaction mechanism in theories. So here you have to understand what is the reaction only. Yeah? So what will happen is hydrogen atom is taking a chlorine from this acid halide and producing HCl. So first of all, let me write down the byproduct of this, HCl. Then you can see that this carbon atom, so this group is remaining, C double bond R. So this C double bond R is connecting to the benzene ring in this way. So finally, you can see that we have obtained a ketone which is containing an aromatic compound, aromatic benzene. So therefore, we have started from benzene and we have ended up with a ketone because of this carbonyl group. So this is known as Friedel-Crafts acylation, right? As a catalyst, we can add anhydrous aluminium trichloride or else aluminium tribromide, any kind of a compound, right? So not only chlorine, we can add acid halide here. So therefore, what will happen? Chlorine is eliminating with the hydrogen atom. So HCl is a byproduct. So C double bond R, right? So the remaining group is connected to the benzene ring in this way. So this is the Friedel-Crafts acylation. So let me consider a simple example here. We can consider, just imagine we have benzene ring. We are going to add CH3, C double bond Cl. and I'm going to add anhydrous aluminium trichloride. So what will happen? So here we know that there is an hydrogen atom. That hydrogen is eliminated with hydrogen. Then C double bond or CH3 group is connecting there. Then we have this kind of HCl. Right? Another example. Number 2. We have benzene. We are going to add CH3, CH2, C double bond or Br. And here we have anhydrous aluminium tribromide. Aluminium trichloride also can be taken, right? It doesn't matter. It doesn't matter that since we have used bromine, definitely we have to use aluminium bromide. So there is nothing like that. We can use aluminium trichloride, aluminium tribromide, doesn't matter. So remember, students, these are actually known as Lewis catalyst. Do you know that? Is anhydrous aluminium trichloride. So in organic chemistry, in many reactions, we are using aluminium trichloride. Then we are using ferric trichloride, ferric tribromide. Then we are using aluminium tribromide. So these actually considered as Lewis catalyst, right? These are considered as Lewis catalyst. Write down somewhere. These are Lewis catalyst. Why Lewis catalyst? Huh? No, it's not compulsory to put HCl. HCl is a byproduct. So in reactions, we don't have to. Right, okay. Right, okay. Sorry. So we can start the class again. Okay. So students, remember, so look at the second example. In the second example, as we can see here we can see that, so this is the benzene ring, and we can see that bromine is eliminating with hydrogen, and C double bond of CH2, CH3 group is there. And here HBr is there. So this is the compound. Okay. Second example. Can you clear it on the second example? Quickly, yeah. Third example, we have benzene ring and we are going to add CH3, C, CH3, H, C double bond, Cl, and anhydrous aluminum trichloride in this way. Okay. So then what should be the product? So we can consider that the product is C double bond, C, CH3, CH3H plus HCl. So this is the third example. So it's very easy. Huh? What will happen? In the acid halide, the chlorine atom and the hydrogen atom in the benzene ring. So both are eliminating as HCl, HBr, HCl in this way. So then we'll have this kind of a ketone. We can say benzoketone, right? Benzene containing ketone. Next example, number 4. So the fourth one should be benzene. What about benzoyl chloride? So that is also acid halide. Benzoyl chloride and then anhydrous aluminum trichloride. Now then we have this kind of a two benzene rings in this way. Okay. Quickly write down. Very easy. Yeah. So remember, the reason why we are considering these are Lewis catalysts is actually they are not satisfying the octane. We know that aluminum trichloride. Students, we have learned about Lewis acids and Lewis bases. So therefore, aluminum trichloride. Aluminum trichloride is Lewis acid. So therefore, since it is a Lewis acid, we can consider. So here we are using them as catalyst. Then we are using that Lewis term and tell that Lewis catalyst. AlCl3 is a Lewis catalyst. AlBr3 is a Lewis catalyst. FeCl3, FeBr3, everything is a Lewis catalyst. Number 5, example number 5. In this way, right? So hydrogen atom here is eliminating with chlorine. HCl is a byproduct, right? So here also HCl is a byproduct. Let's learn the reaction mechanism later. We are going to learn the reaction mechanism later. Are we done? Now let's go for the exercise and we can revise all the reactions we learned up to now. Let's see. Number one, benzene ring, C double bond of CH3, CH3, CH3. Quickly, Rano. Quickly complete these reactions. So what are the reactions? CH3C double bond O Cl anhydrous aluminum trichloride. CH3MgBr here and H3O plus. PCl5. And here we can add the sodium derivative of the alkyne. And CH3Cl. PCl5 here. So here they have given the acid halide. So we have to add benzene ring and anhydrous aluminum trichloride. MgCl, H3O plus, PCl5, alcoholic KOH. So this is the way. Number one and number two. So I'm going to erase the first one and do the third one. So you have to do these things quickly now. Now you have some kind of an experience. You know that we have done some reactions. Right? So therefore, so third one. So third one should be like this. Number three. You can't see it. So the last compound is given. Third one should be like this. Alcoholic OH is added. Sodium is added. CH3Cl is added. H3O plus mercuric cation is added. And here we have CH3MgBr. Secondly, H2 plus. PCl3. Then we are adding alcoholic KOH. Okay, so quickly do them. In the third one, we have to go for the reverse. Benzene, CH2OH, CH2CH3, and here we have CH. So before this one, actually, we have a green out region, right? So what are the green out region? Benzene, CH3, MgCl, right? So before that, we had alkyl halide, CH2CH3, CH3Cl. Look at this one. Here we have OMgCl, CH2CH3, and CH3. CH2. Oh no. So wait a minute. So here this one should be C double bond CH3, a ketone which is contained in benzene. Then tell me, so this is the reaction we learned. This is the first reaction that we learned today. So according to this reaction, what are the previous compound that we had? So definitely that one should be benzene. So the reaction is started with benzene, and likewise we have the flow in this way. So let's move to the fourth one. In the fourth one, very easy, right? Everything that we learned. So alcoholic KOH is added. So students, this is a dihalide, vicinal dihalide, right? So therefore, alkyne is produced in this way. Sodium is added. So therefore, we can say that we know that this alkyne is actually acidic. Since it is acidic, C minus Na plus, CH3Cl is added, and here CH3. Right? Very easy. What will happen? Sodium plus is eliminating with the chloride anion, and CH3 is coming here. So when we add H3O plus in the presence of mercuric cation, so what will happen? Now here we can say that, so this is addition of water to the alkynes. So we can follow the Markovnikov rule. According to the Markovnikov rule, we can say that. So these are the two carbon atoms. Oxygen is connecting to this right-hand side carbon, and two hydrogens are connecting to the left-hand side carbon. Because Markovnikov rule says that the rich one get more richer. So therefore, hydrogen should be connected to the carbon atom, who is already rich with hydrogen atom. So therefore, we can consider CH3, C double bond or CH3. Now here, this is CH3MgBr, green out region, and H3O plus. So therefore, CH3. So PCl5 is added. So therefore, CH3, Cl, CH3, CH3. Alcoholic KOH. alcoholic KOH is added. So therefore CH3 double bond CH2 like this. So this is the final product that we can obtain. Yeah. Number 4. Yes, Rushada, that's depend on the that is depending over on our need. So what we need, if we want 2 sodium plus, you can put there, doesn't matter. That means when we add CH3, we will have an alkyne with 4 carbon atoms. So that's depend on our need. So here we assume that we need only one. We have to increase only one carbon atom here for one side. So we don't need the 4 carbon atoms, 3 carbon atoms are enough. So therefore I can consider it this way, right? And one more thing, in some actually references, they have given that when we add excess sodium, then we can say that these 2 hydrogens are eliminated and 2 sodiums are connected there. So that is depending on our need. So here, if someone has written with 2 sodium plus, so that is also correct. If someone has written in this way, only for one side, that is also okay. Anything is fine. No, it's not wrong. Nothing wrong with that one, but you can choose any method, doesn't matter. Both the hydrogens are acidic neither. So therefore, we can do both. Shall we move to the fifth one? Number 5. Benzoic acid. For the benzoic acid, we are adding PCl3. So here we are adding benzene and anhydrous aluminium trichloride. CH3, CH2, MgCl. And then we have added H3O plus. PCl3. ACl. So this is the fifth one. So let's move to the sixth one, number 6. Number 6 is actually a conversion. Benzene ring and in this way. Right? So can you try this one? So here you have only 1, 2, 3, 4. Not more than in 4 steps. Not more than in 4 steps. First of all, let me do the fifth one. Fifth one is very easy. We can form benzoyl chloride. Benzene is added in the presence of anhydrous aluminum trichloride. Here this one should be OMgCl. Then H2O plus is added. CH2, CH3. PCl3 is added. Cl, benzene ring, and CH2, CH3. Can you remember? Potassium cyanide, alkyl halide with potassium cyanide. So what will happen? So cyanide will come instead of chlorine. Okay? So therefore we can say that cyanide 2 . Anyone here completed this number 6 conversion? Not more than in 4 steps. Raise your hand. Anyone here completed that conversion? Rushada, Nabil, very good. Huh? Very good. Rihama, okay, good, very good. Easy, right? It's not difficult. Huh? Quickly, others also. Right. Students, check your answers whether you have done this conversion in this. So first of all, I'm going to add benzoyl chloride, anhydrous aluminium trichloride. Then we have this kind of a compound. Right. Then what we can do, we can add here number 1, benzene magnesium bromide, H3O plus. In this. Then PCl5 is added. And KCl. Easy. That's all. So there is no difficulty in this conversion. Huh? It's very typical, very easy conversion. Understood? When you analyze the past paper conversions now, recent years, 2024 and 2023, the conversions they have given is not difficult. Huh? Those conversions are easy. Sometimes they ask into the conversions within 3 steps, 4 steps. So therefore, that's very easy. But remember, students, so when you analyze the papers are before 2019, So before 2019, 2015, 14, 13, they have given difficult conversions. Huh? So we have to prepare for everything. We don't know what kind of a conversion that we will get in our 2025 exam. Maybe it is easy or difficult, right? So our last 2 years conversions were very easy. Maybe in this year, conversion can be difficult. So therefore, we have to practice a lot, right? Right. Okay. So with that, carbon increase in reactions number 4 is done. And next, we are going to discuss about another special conversion reaction number 6, right? So quickly complete this one. So raise your hand who understood these things up to now, the reactions that we discussed. Do you have any doubts here? Good. Right. If you have any doubts, let me know. Huh? And one more thing, students, I have created the group to discuss the doubts. Okay. If anyone has organic chemistry, anything that you don't know or anything that you want to share related to organic chemistry, so you can share that one in group. Huh? It doesn't matter. You are allowed to put the things that you want to share related to the lesson organic chemistry in the group. Okay. If you want. So later we can discuss some the exam questions, right? FWC paper questions, difficult questions, past papers, right? Isomerism past paper questions, likewise. We can have a discussion on that. Huh? First of all, you have to come to the track. Islam track end. Podda conversions karala track end. So remember one more thing. I'm not teaching these conversions for the talented students. Huh? Again, දක්ෂ ළමයින්ට මේව ඕනේ නැහැ. මට ඕනේ අර average එකේ ඉන්න ළමයින්ගේ පොඩක් උඩට ගන්න. Can you understand? Most of the students are average students. So I want to see that they are doing conversions. So like the talented students without any effort. So ඔයගොල්ලෝ A level එකට එන්න ඕනේ. A level එකට එන්න තමයි ඔයගොල්ලෝ කරන්නේ. Can you understand? So write down the heading special conversion reaction number 6. Reactions number 6. Write down this way. Reaction of Grignard region with active hydrogen in compounds. Write on the heading, reaction of Grignard region with active hydrogen in compounds. Okay, active hydrogen. So we have discussed about active hydrogen before. Where exactly? Under the reactions of alkynes, can you remember? I told you 4 important reactions are there in alkynes. Right? If there is a terminal hydrogen, yes, this active hydrogen is actually a type of active hydrogen is terminal hydrogen, acidic hydrogen in alkyne. Can you understand? So because that is acidic, that acidic hydrogen can react with some kind of bases. Sodium, we discuss about sodium metal, sodamide, NaNH2. Then we discuss about what? Ammonia copper chloride. And then ammonia silanitrate. Right? So likewise, we can consider 4 reactions. Okay. First of all, let's identify the compounds with active hydrogens. Compounds with active hydrogens. Before we go for the reaction, you have to know that what are the compounds with active hydrogen. That's what you have to know. Students, I'm going to tell you that there are mainly 3 types. So the first type is actually OH. OH group. In OH group, we know that OH bond is actually polarized. Oxygen atom is the second highest electronegative atom in the periodic table. So therefore, what will happen? Electrons are pulled by oxygen. This hydrogen is acidic, active hydrogen. Normally, this hydrogen is easily reacting with the compound since it is acidic. Because this bond is polarized, oxygen is pulling electrons, hydrogen can easily eliminate from the compound. Right? So let's consider a few examples for this. What are the examples? We can consider some example reactions like water molecule. Yes. So water molecule is containing as active hydrogen because OH group is there. Hydrogen peroxide, H2O2. Yes. Then we can consider methanol, all the alcohols, carboxylic acids, acidic acid, CH3, C double bond OH. In carboxylic acid, we know that C double bond OH, OH group is there. Right? Then sulfuric is there, H2SO4. So likewise, we can see that OH groups in all the compounds. So they are acidic. They are active hydrogens, right? So like in OH, remember the second type is a NH, nitrogen which is connected, hydrogen which is connected to nitrogen. Examples. What are the examples? Friends, in organic chemistry, we know that amines, primary, secondary, tertiary amines are also having acid, active hydrogen, right? They are considered as bases, but hydrogen can eliminate, right? When Grignard region is added to that one, hydrogen can eliminate that one as a acidic hydrogen, active hydrogen. Because again, the reason is, what is the reason? Reason is electronegativity. Then ammonia, NH3, methylamine, CH3, NH2, right? So dimethylamine. So likewise, we can write down many compounds, many examples, which are having NH groups, right? So that is the second type. And the third type, you already know it. What is it? The third type is carbon, triple bond carbon hydrogen. This hydrogen is active. So we already know about this one. We have discussed this one. This hydrogen atom is acidic. Why? The electronegativity of carbon atom is we have precision. Then we can say that this hydrogen is easily removable active hydrogen. Active hydrogen. So therefore we can consider ethyne. So these hydrogens are active. And here we can say that this hydrogen is. So these are the three types of compounds, major compounds that we can identify as compounds with active hydrogens, right? Compounds with OH group, compounds with NH group, and compounds with acetylide anion, right? That means a hydrogen is containing there in the triple bond. Okay. Quickly write down this one. Now we can consider a few example reactions, but before that, quickly. Okay, are we done? Shall we go for the example reactions? Yeah. So let's now look at this one now. Now look at this one very, very carefully. Yeah. 2016 organic chemistry conversion is related to this reaction. I can still remember that one because that was my first try. So I also didn't do that conversion. So many students couldn't identify that one properly because is it's not that much of famous reaction, right? This is kind of a hidden reaction in organic chemistry, right? So therefore, so let's consider some example reactions. The Grignard region is reacting with active hydrogen compounds. Look at this one. CH3 MgCl, it's going to react with water. Okay. Right? Look at this one. Look. So does you know that now, as we discussed in water molecule, OH group is polarized. So there will be hydrogen. I can write down the water molecule in this way, OH and here H. So among the CH3 and MgCl group, you have to identify which one is positive and which one is negative part. Now, when you consider, now we can separate this one, MgCl and CH3. Magnesium is alkaline earth metal, which is positive one. Then we can say that this is the positive one, delta plus, and CH3 is the delta minus negative part. And in water molecule, we know that hydrogen is delta plus, oxygen is delta minus. Then now you know what to do. You know what to do, right? What we have to do? You can break the bonds in this way. Hydrogen is connecting, CH3 is connecting to hydrogen, OH is connecting to MgCl. So therefore, you can see that positive one is connecting to negative one is connecting to positive one. Then CH3 is added to one hydrogen, methane. Then next one, MgClOH. Can you understand? MgClOH. OH, MgCl. Anyway, you can write down that one because it doesn't matter because we are just considering this one as the byproduct. Okay? I'll tell you where we have to consider about this one much, right? But in these kind of cases, we don't have to worry about that. Understood? This is the first example. So raise your hand who understood that one. It's very easy. Yeah? Raise your hand who understood that. Can you understand how we can separate that one? How that Grignard region is reacted with that compound? Remember, students, in Grignard region can be separated into the negative part and the positive part. Always in the Grignard region, this alkyl group is the negative part. MgCl part is the positive one. Then in the compound that we have added, you can separate the what is the positive one and negative one. According to this bond difference, electronegative difference, we know that OH, oxygen is negative, hydrogen is positive. Then accordingly, we can break the bonds. You can connect the positive part of the compound with the negative part of the other compound and the other part also. Very easy. Now let's go for the second one, second example. In the second example, we have CH3, CH2, MgBr. Is added to methanol CH3 OH in this way. Make up easy. So this is also easy. Why? Alcohol OH group is there. So we can say that me how easy? OCH3. So students, we can separate the bond from here. Delta minus, delta plus. And CH3 MgBr, we can break that one in this way. MgBr is delta plus and this is delta minus. Then hydrogen is connecting to this compound. Then it is producing CH3, alkane, ethane. And we can say that, what is the byproduct? What is the byproduct? Interesting. MgBr or CH3. Okay, actually, that one should be written as like this. Mg should come here and Br should be written like this. Okay, so we don't have to worry about that byproduct here. So you can write down this compound as you wish. So here also Cl can be connected to there and OH can be connected here in that way. So that means, so let me write down in that way. Oh, in this way. Okay, we can consider in that way. It's not exactly a covalent bond because magnesium is actually an alkaline earth metal. So can't we separate CH3 from the compound using OH as 1. No. We can't separate CH3. Yeah? Asma, we can't do that one. Remember, our topic is reaction of Grignard region with active hydrogen, not with the OH group. Neither. So, if it is active hydrogen, not OH. Huh? Third example. Right. So, this is very interesting. Huh? Benzene, magnesium iodide, is reacting with D2O. What is this D2O? So D2O also same as H2O, neither. Why? Deuterium, isotope of hydrogen. Right? So obtain the product value. Let's see how we can go for the answer. Try to get the answers. So before you go for that one, MgI, and here we have H2O. So let's do this one. So same thing, in H2O, we know that we have hydrogen and OH. So therefore, this will break from here. In MgI, this will break from here. This is positively charged, and benzene will be in delta minus. And then what will happen? Hydrogen is taken by benzene ring and MgIOH. Then we can write down benzene. Benzene is produced. So MgIOH in this way. Easy, right? So we don't have to mention this hydrogen. Already we know that hydrogen is there. But in the compound that they have given, in the Grignard region, not hydrogen, there was MgI, magnesium iodide. So therefore, this is the compound. Got it? Then tell me what is the result for this one. What is the product for this one? You think, students, D2O means we can say that D, deuterium OD, hydrogen OH, right? Like hydrogen OH. Then this will break from here, MgI OD, and benzene is connected to D, deuterium atom, MgI OD. Can you understand? Right? Very easy, right? I'm going to teach you this one under the production, the way of producing benzene. This is also one of the reason. This is also one of the way that we can produce benzene, right? When we have benzene magnesium halide, when we add water, we can obtain benzene. Benzene magnesium halide reacting with water to produce benzene. Yeah. So quickly write down this one. Done, right. Now let's go for the next one. Number 4, fourth example. So fourth example is it's not that much difficult. In this way. Now you know what is the active hydrogen. What is the active hydrogen? So this is the active hydrogen, delta plus, delta minus. Bond will break from here. MgCl, delta plus, delta minus. Bond will break from here. Then hydrogen is connecting to this one. Then it is producing CH3, right? Then CH3, C triple bond C, MgCl. Students, can you remember I told you that 2016, right? Now after the class, you can watch 2016 A-level organic conversion. That organic conversion is done by using this Grignard region, right? So we never think about this one. We learn this reaction. Our teachers also taught this one, but we didn't. අපි ගණන් ගත්තේ නෑ. Right? So we didn't consider this one. Right? Since it's the byproduct, we don't need this one to do the conversion. Likewise, we thought. But in that conversion, this is the product that they have used, not this. Because we know that we can't do anything with the alkanes. Alkanes are not that much reactive. But this green arc region, this is reactive. Now hereafter we can do some reactions. Okay? This is also a type of a green arc region. Okay? This is also a type of a green arc region. We can use this green arc region to increase the number of carbon atoms. So this is very special. Huh? So put 2-3 star marks on this reaction, and you can see 2016 A-level conversion that they have given. Look at the past papers. They have done this that conversion using this reaction. Right? So this is the fourth example. Quickly complete it. Now, okay, right. So look at this one. So here we have this kind of a green arc region. Carboxylic acid is added this time, CH3C double bond OH. Then OH group is, we can say that OH group is acidic. So bond is breaking from here, delta minus, delta plus. Hydrogen is connecting to this alkyl group. Then it is producing propane. And this remaining negatively charged group is connecting to magnesium bromide and forming this kind of a compound. Okay. If they ask you what is the byproduct, you should be able to write down this. Number 5. Right, okay, last one, last example. So likewise, students, you can separate that compound from hydrogen and connect to the negative part of the green arc region. That means alkyl part. Then write down the products. That's all. Last example, number 6. We have green arc region CH3, CH2MgCl, and we are going to add CH3NH2. Right. Then what will happen? This is delta plus, delta minus. This is also broken, delta minus, delta plus. Then the product, CH3, CH3. This hydrogen is connected to the alkyl group in this plus CH3NH MgC. Okay, so this is the 6th one. That's all. These are the reactions. Quickly write down these reactions. If you have any doubts, put your doubts in the chat box. Huh? What do you mean by this hydrogen? No, 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 no. Remember, we can't consider that the both the nitrogen atoms are acting as acidic hydrogen. No? Only one. Only one. No? One at a time. Right, okay. Students, then shall we go to some exercises by adding this reaction also? Okay, right. Now you can see that we have increased reactions one by one. Either. Remember, you have time. Can you understand? So now, so we have 8 months more. So therefore, students, you have 8 months to practice this organic chemistry conversions, reactions, reaction mechanisms, all the theories. You have time. Remember, organic chemistry is actually 4 units. So you can collect more than 20 marks from organic chemistry parts. So therefore, be careful. So be patient and do the questions, right? So it will take some time to develop, but what you have to do is continuously do it. Okay. Benzene is here. Cl. Let me write on the second one also. So I2 means there are two hydrogen atoms are connected to the carbon atom. Huh? Try to understand what I have written here. Two hydrogen atoms are connected to that one. quickly complete these two conversions. So let me go to the first one. So in the first one, students, we can say that CH3 C double bond of Cl is that. MgBr, secondly H3O plus. PCl5, magnesium dry ether, and secondly H3O plus. PCl5, magnesium dry ether. So what do you think? What is the compound we have to add here? Huh? What is the compound we have to add? So anything with acidic hydrogen, right? Not only water, right? So look at the product that we have obtained. So CH3, right? Only hydrogen should be connected to here. Another hydrogen should be connected to here instead of MgCl. So therefore, any active hydrogen containing compound can be added here, not only water. So let me write down here in this kind of. What do you say? Yeah, that's also okay, fine. Okay. Byproduct is another one. We know that it is a separate thing. CH3, C triple bond, C MgCl. That's a byproduct. We know it, but this is not our main focus. So we need to have this compound. So therefore, we don't worry what is the compound we are going. So what is the compound that we have to add here? What we have to add here? So we have to add alcoholic KOH. Sodium. CH3Cl. Mercuric cation H2O plus. Here we can add CH3MgBr. H3O plus. PCl5 magnesium dry ether. And so what is the compound we have to add here? So D atom is connected here. D. Then yes, D2O. We have to add D2O. Okay. Shall I erase first one? Hmm? Are we done with the first one? PCl5 is added here. So here we have added benzene ring and anhydrous aluminum trichloride. So here CH3MgBr. Secondly, H3O plus. Okay. So this is CH3MgBr and H3O plus. You can see that one. PCl5. Magnesium diether. H3O plus. Shall we go for the fourth one? Yeah, in the third one, the final, sorry. So the final one should be shall I raise second one? Are we done with it? No, this is hydrogen. Sorry, this is hydrogen. Now you have that confusion. Eh? So normally you have learned that after adding H3O plus, you have normally OH. Ne? Now this time here we have hydrogen, right? So then you have to understand here they have used the reaction that we have used now. What we learn now. Grignard region with the acidic active hydrogen containing compound, right? So magnesium diether is added for to form Grignard region. So H3O plus, right? So what is the difference between H3O plus and H2O? Only H plus is added. So in H3O plus already we know that H2O there. Then you have to understand there. So this is the reaction with the Grignard region and water. Neither. Very easy. You have to understand those things. Huh? In this way. Do the fourth one quick. So we can do the third one. Students, we have to go for the reverse. So just imagine this is a water molecule, right? And then we can say that the previous compound is definitely that one should be Grignard region, MgCl, right? Then here we have alkyl halide like this. So here we have alcohol OH. In this step, what we have? We have a ketone like neither in this way. And here we have benzoic chloride and started from benzene. Wait a minute. Not benzene. Benzoic acid, ne? Because PCl5 is added. So raise your hand who put here benzoic acid. Raise your hand who put the benzoic acid correctly. Or did you put benzene like me? Okay, good. What about fourth one? PCl5O, PCl3. So here we can add benzene ring, anhydrous aluminum trichloride, CH3 MgCl, H3O plus, PCl5. So what is the region we have to add here, as you think? What is the compound we have to add here? Yeah, any kind of a green art region, any green art. Yes, we can add any kind of a green art region, doesn't matter, right? So I'm going to add here the simplest green art region, CH3 MgCl. So what will happen? Instead of this hydrogen MgCl is coming here, this CH3 is eliminating with hydrogen. So byproduct is methane. So it's not in our concern, but you can understand that byproduct is very easy. So here is the code. Right, okay. Students, number 4, number 5, number 6, number 7, there are 3 conversions. You have to do that one as a homework. Okay. So I didn't put the answers for the last 2 conversions. Okay? So I'll put that answers. So today also I'm going to give you some conversions. Number 5, number 6, number 7, they are homework. First of all, complete this. Not more than in 3 steps. Okay. The first homework. So the next one, chlorobenzene and CH2D. Not more than in 5 steps is the second one. Okay. And write down the third one. This is very interesting. CH3, CBr, Br CH3 not more than in 7 steps. Right? So quickly write them. So this is the homework. Quickly copy down the homework. Right, okay. Students, shall we go for the next reaction type? Quickly. So do these 3 as a homework. Huh? Anyone here completed these 3 reactions now? Anyone? So I completed this one. At least 2. First 2. Anyone here? Okay, very good. Mariam, very good. Huh? Good. So third one is very interesting. Sometimes I don't know. You can do this one within 4 steps, 3 steps, 5 steps. Sometimes maximum you have to go for 7 steps, right? You can try, yeah. Special conversion reaction number 7. Special conversion reactions number 7. Okay. Oxidation of alcohols. Very, very important reaction. Oxidation of alcohols. Right. Now listen this one very carefully. Yeah? Students, this reaction is very, very important. So therefore, look at this one. So under the oxidation of alcohols, let me consider, first of all, primary alcohol. Okay. In the case of primary alcohol. So in the case of primary alcohol, what will happen is, so here we have R group, CH2. So this is the OH group and CH2. So only one alkyl group is there. So therefore, this is primary. So in order to oxidize, we are going to adhere strong oxidizing agent, right? Do you know what is the famous oxidizing agent? In acidic medium, we are going to add potassium permanganate because we know that permanganate is going to reduce into Mn2 plus in the presence of acidic medium. So therefore, it is well used oxidizing agent, right? So this is the most famous and most used oxidizing agent in organic chemistry. So what happened here is, you can understand here, remember this is actually producing an aldehyde, first of all, C double bond OH. RC double bond to H. This is what happened exactly as the first step. So what is the reaction mechanism and everything? We can learn those things in theories. Huh? So here I'm just giving you the reaction. What is going to convert into what? Okay, that's all. So if you want, you can check the oxidations also, right? Oxidation numbers. Okay. Here carbon, here, sorry, we can say that +1 -1, +1 -1, here -1 +1. So RR, we know that carbon is there, so therefore no difference. Here oxidation number is -1. So oxidation number of carbon is -1. So when you consider this one, here you can see that +1 -1, and here -1 +1, -1 +1. So therefore here oxidation number is +1. So carbon is oxidizing. So that's why they have given a name like oxidation of alcohols, right? So the carbon atom which is connected to the alcohol group is oxidizing. So who is the oxidizing agent? Acidic KMnO4. So first of all, it's going to convert into this kind of an aldehyde. But remember, students, this aldehyde is also again further oxidizing into carboxylic acid. So therefore, the final product of oxidizing of alcohol is what? Carboxylic acid. Carboxylic acid. Further oxidizing, -1 +1, -1 +1, -1 +1. So carbon's oxidation number is +3. Further oxidizing. Can you understand? So therefore, tell me, when we add, right? When we add oxidizing agent, strong oxidizing agent, like acidic KMnO4, primary alcohols are going to convert into what? Carboxylic acid, C double bond OH. If you want to convert alcohols into carboxylic acids, primary alcohols into carboxylic acid, you have to add there a strong oxidizing agent like acidic KMnO4. Acidic KMnO4, right? Remember, moreover, in your resource book, students, they have given not only acidic KMnO4, you can use here acidic dichromate, K2Cr2O7, right? And acidic CrO3, right? Can also be used to oxidize these primary alcohols, right? Acidic dichromate, H plus K2Cr2O7, or else acidic CrO3. Here chromium's oxidation number is +6, here also +6. Same thing. Same chromium can also be used. Okay. So this is the case of primary alcohol. Okay. So I want to teach you another thing, another point. So first of all, come up to here, write down these things. Write down this one quickly. Right, okay. Are we done? Quickly. Now look at this one, friends. sometimes in conversions, remember, we don't have to go for the carboxylic acids. We can stop the reaction at the aldehyde stage. How we can stop the reaction at aldehyde stage? Right. Remember, students, in order to stop this reaction at the aldehyde stage, we are going to treat this primary alcohol with another compound, right? Instead of acidic KMNO for acidic dichromate to acidic CrO3, we are going to add there another different compound. Look at this one. Okay? Listen to this one. The oxidation reaction, write with me. Take the red color pen and write down. The oxidation reaction can be stopped. Can be stopped at aldehyde stage. At aldehyde stage by adding. Okay? Listen to this compound. Look at this one compound. This is known as pyridinium chlorochromate. Write down that one correctly. Pyridinium chlorochromate. Pyridinium chlorochromate. Remember, students, unfortunately, you have to remember the chemical formula of this one. Right? We can't say that these things are not coming for the examination. You have to remember these things. Look at the pyridinium chlorochromate chemical formula. C2H5 NH plus and CrO3 Cl minus. So this is known as pyridinium chlorochromate, right? So the short form is PCC, pyridinium chlorochromate. Short form is PCC. So we can stop this reaction at the aldehyde stage, right? Without continuing up to carboxylic acid, we can stop this reaction at the aldehyde stage by adding pyridinium chlorochromate. C2H5NH plus CrO3Cl minus. So cation and an ion can be an ionic compound. Short form, right? In conversions, you don't have to write down the chemical formula. You can just write down PCC. It's okay, fine. But if they particularly ask what is the chemical formula of PCC, you should know that one also. Right? Because they have given this thing in your resource book, right? So therefore, you have to know the chemical formula. Can you understand? So these kind of points are important, right? Can you remember in inorganic chemistry, we learned that under the group number 15, Brown ring test. So they are also a chemical formula that you have to remember. FeNO plus. Points right? So these are the points in the resource book. Right? Students, most of you are doing organic chemistry, right? Most of you are doing biology, right? So therefore, so you know what is the priority that you have to give for the biology resource books. So likewise, for the organic chemistry, for the inorganic chemistry resource book, you have to give the priority. Can you understand? You have to give the same priority for the inorganic chemistry and organic chemistry resource book. Understand the theories well, right? Try to get the theories, remember the theories. Especially when you go for the inorganic chemistry, the table that they have given under the D block, final table, the complexes colors, you have to remember that. Photocopy right? So when I ask you what is the color of aqua complex, amine complex, chloride complex, you should be able to tell that directly, right? Quickly, you should be able to tell that. Right, okay. So therefore, students, we can write down this reaction in this. Now write down this one again. we have a primary alcohol RCH2OH. We can convert that one into an aldehyde by adding PCC. Primary alcohol is converted into an aldehyde by addition of PCC. Okay, by addition of PCC. Quickly write down this one. So we learned that when we add acidic KMnO4, what will happen? Right? We are adding acidic KMnO4 or else acidic dichromate or else acidic CrO3, anything. What will happen? So this will convert into carboxylic acid. Right? But when we add PCC, what will happen? So that is stop at the aldehyde stage. So you have to remember this one. Primary alcohols, huh? Primary alcohols. So with PCC, the KMnO4 is also needed, right? No. Only PCC. Only PCC enough. Okay. Only PCC is enough. Huh? We are not going to add acidic KMnO4 there. Only PCC. PCC is enough. If you go for the lab, actually, you can see that one. PCC actually solution is there. They have mentioned that one in the bottle. PCC. You go to the chemical lab and see, will you? Now, what is the case? What is the case? Presence of secondary alcohols, right? Secondary alcohols are not like primary alcohols. Whatever the region that we are going to add, it can be acidic KMnO4, acidic dichromate, acidic CrO3, or PCC, anything. It will definitely convert into ketone, right? Remember, students. Now here we have secondary alcohol. In the case of secondary alcohol, R, C, OH, R dash, what will happen? This is directly converting into ketone. It can't go for the carboxylic stage, R dash. Okay, so therefore it can be acidic KMnO4, right? Or acidic dichromate, acidic CrO3, or even you can add PCC. What will happen? Still there is giving ketone, right? So secondary alcohol is converted into a ketone. Secondary alcohol is converted into a ketone by addition of any kind of oxidizing agent like this. Okay. So actually, why it can't go for the carboxylic acid? The one of the reason is having two alkyl groups. Two alkyl groups are there. But in primary alcohols, we know that only one alkyl group was there. It can easily go for the carboxylic acid stage. But in the ketone case, we can't do that because there are two alkyl groups. So therefore, we have to stop from the ketone stage, right? Secondary alcohols are converted into ketones by addition of acidic KMnO4, acidic dichromate to acidic CrO3, PCC, any oxidizing agent. Actually, these are the four oxidizing agents they have here. Okay. Quickly, very easy. So this is what happened in the presence of secondary alcohol. Okay. Right, okay, are we done? Right. Students, what do you think about tertiary alcohols? We have tertiary alcohols. Oxidation of tertiary alcohols. Let me take R double dash. Students, remember, there won't be any reaction. There won't be any reaction for the secondary alcohol with these oxidizing agents. The reason is by addition of these things, tertiary alcohols cannot be oxidized. The main reason is having these kind of three alkyl groups is stabilizing that compound. So therefore, tertiary alcohols won't easily oxidize by addition of these kind of oxidizing agents. No reaction. No reaction. Okay. There won't be any reaction. Okay. But remember, if there is a benzene ring, okay, if there is a benzene containing tertiary alcohol, then it will convert into a, by addition of acidic KMnO4 kind of oxidizing agent, it can be converted into benzoic acid in this way. So that is actually to protect the stability, of aromatic ring or benzene. Let me write an aromatic ring, right? So this is to protect the stability of the benzene ring. Otherwise, tertiary alcohols won't oxidize. That's what you have to remember. If they have given a tertiary alcohol containing benzene, then you can write down benzoic acid is benzoic acid, type of a carboxylic acid. Okay, to protect the stability of the aromatic. Okay, put note and write down that one also. Right, okay, are we done? Right, okay. Students, let's do a small exercise on this reaction as well. Quickly write out. Number one, primary alcohol benzoic acid. Okay, so this is carbonyl group. Second one is very interesting, isn't it? CH2D. Quickly complete these conversions. In here, we can consider acidic chem, PCl5. So here we have added aromatic ring, anhydrous aluminium trichloride. CH3 MgBr is added. H3O plus, PCl5, magnesium drive. And here we can say that D2O is added. Alcoholic KOH, sodium, CH3, CH2, CH. Then, so here they have acidic hydrogen and it is converted into MgBr, which means definitely they have added Grignard region. So simple Grignard region like CH3MgBr. What do you say? Then CH3 is eliminating with hydrogen, methane. So it's not the main product, major product that they have taken for this conversion. They have taken byproduct. That's why I told you, right? In conversions, they can use the byproduct also. So what do you think about this one? Then here CH2OH. First of all, they have added methanol. Secondly, H3O plus is added. And this kind of a compound is. Here they have added PCl5. Again, magnesium triether. We can say that D2O is added. Either. If hydrogen comes here, you can say that H2O. Easy. Simple as that. Here's the second one. Quickly complete these two conversions. Right, okay, are we done? Shall we move to the next one? So look at the third one. a flow chart like this. How we can do this? CH3, CH2Cl. Magnesium diether is added, so therefore green oxygen, MgCl. So can you remember PCC added? That means primary, sorry, aldehyde is produced. So that aldehyde is Grignard reacting with H3O plus. Then we can say that CH3, CH2, CH3, OH. So acidic KMNO4 is added. So therefore carboxylic acid is produced. Tidal-Craft acylation, the first reaction that we learned today. So this is it. No, alkyl group in aldehyde is this one. CH3, C double bond OH. This CH2OH group is converted into C double bond OH. Okay. Can you understand? Then again, Grignard region and ketone. So be careful when you are writing the products for this one. OH, CH3, CH3, H, CH2, CH3. Yeah. PCl5 is added. It is converted into chlorine. Yes. So in the examination, you will sometimes maybe you may given this kind of a conversion as well. A flow chart. Ne? Right, okay. Are we done? Quickly complete this one. Right, okay. So do this one as a last conversion. Number 5. CH3 MgBr is added. H2O plus is added. So here we can say that CH3 OMgBr CH3H so this is secondary alcohol. So even though when we had acidic KMnO4, it's ended up with ketone. Then green heart region is added. H2O plus. In this way. CH3 MgCl is added. So green heart region is reacting with active hydrogen. Okay. Quickly complete this. Are we done with this or no? Students, I'm going to give you another homework. Shall I erase this one? Do you need more time to write? So you have another homework. Do this one also, right? So what is the next homework is? So I gave you 3 conversions and I'm going to add another 2 conversions to that one. CH3, CH, ER. So you have to do this conversion not more than in 7 steps. And the next one is this. Three steps. Just 3 steps. No. Okay. So addition to the previous 3 conversions, you have to do these 3 conversions also. Okay, right. So these are the things then we have to discuss today, right? So raise your hand who understood the things that we discussed today. Do you have any doubts here? Are we clear? Now, little by little, we are increasing the number of reactions. Right? Yeah. So how do you feel now? What do you feel about the organic reactions? Hmm? Did you try past paper conversions? Yeah, easy. These things are very easy. Okay. So that's what I'm telling you. So since this is easy, definitely you have to get that 20 marks in this paper. In the LL paper for organic chemistry, right? Okay. Right. Okay, right. So then students, do these 5 conversions as a homework. Some of you already sent me that. I think Mariam sent me the last 3 conversions. Now these 2 are also very easy. So you can complete this one. And let's meet on the next week class then. Okay, fine. So Friday we have the paper class. We are going to discuss that paper. I sent you the paper book. Okay, students. So did you get the paper book? So who are my paper class students? Did you get that paper book? Okay. So by tomorrow, before Friday, you will get that one. By tomorrow, sometimes you might get all of you, right? I posted that one. Okay, then let's meet on the Friday paper session. Until then, bye bye. Have fun. Good night for all of you. God bless you.